Hey guys, it's Ferdinand Dandy here. You've probably seen Arduino project before from my 3 minutes of video introduction and the formal video introduction while working in Thailand. Well, this video is about looking into the Arduino hardware specific to the power supply. Let's go back to the Arduino project, but guys, sorry for my look today, for having this sunglasses. I got some problem with my right eye, so I decided to wear the eyeglass. I would like to start the Arduino circuit design with its basic need to power up the circuit. To start with, the Arduino comes with the onboard power supply with the recommended range of input voltage from 9 to 12 volts. From its intended use, the Arduino is to be used for audio power amplifiers, for DIYers or builder of DIY power amplifier. Normally, the DIY power amplifier comes with a normal voltage range from plus or minus 20 volt DC to as high as 80 volt DC. That is, even higher, like 125 volts or even to plus or minus 200 volts. Therefore, there is a need to adapt the power supply of the Arduino to that range of power supply, and the criteria that I set is to limit to about plus or minus 30 VDC. Otherwise, the Arduino will have its own power supply. This limit, plus or minus 30 VDC, is mainly for the power amp that I love to do, like the Nathan Winter comp with a single supply voltage of plus 24 volt DC. There are two circuits that coexist on the PCB. The first one is using the popular passive LM7806 regulator power supply, and the second one is using a modular board using a DC to DC boost converter. You can select either one of the solution using a jumper setting, or even you can use the two together, but that will be an extravagant overkill circuit. But if you like it, why not? Go for it. The LM7806 passive regulator can be used when the voltage is not so high, such as 18 to 24 volt DC. This makes the regulator not so hot, while the module is to be used when the input voltage that tap to the amplifier power supply is more than plus 24 volt DC. This means the power supply is cooler. You may ask why I need to use the plus 6 VDC with the LM7806 instead of the LM7805, since the Arduino supply needed is plus 5 volts. That's pretty a good question, and my answer is rather a question why the industry have the LM7806 and also have the LM7805, which is only 1 volt difference. Well, let's take a look at the design and see the diode D3 and diode D4. I use this diode to split the power supply of the Arduino Uno from D4 and the rest of the circuit from D3, like the LCD, several relays, and sensors. So, why I have to do that? I want to split or divide the plus 6 volt power supply from the LM7806 into 2 or more for isolation, which reduces power supply distortion or power supply grabbing between different circuits. Look at it from plus 6 volt DC passing to a diode with a forward bias of 0.7 volt DC. Theoretically, it should come up with a plus 5.3 volt DC. That is fine with a circuit with an operating range of plus 5 volts plus or minus 0.3. that is 5.3 volt DC. We are at the upper end of the operating range. There are more benefits of using the LM7806 plus 6 volts with a diode like signal diode 1N4148 on the power supply, which is beyond the scope of this video episode, example of which is the EMC Compliance. Let's just note of the benefits for more circuit know-how. The power supply design take care of the power management. This idea is to comply with the eco mode or low power consumption of the circuit or device in the standby mode. What it meant by that, you may ask? The LCD, the relay, sensors such as the DHT11 and other circuit must be power off when not in use, and that mode is on the standby mode. The reason for this is to have the least possible current consumption, the best less current consumption, which is why the circuit composed of Q1, which is used as a switch to distribute the power in the active mode, and it is controlled by Arduino Uno pin 10. Sending a logic 0 to Q1 will switch and distribute plus 5 volt DC to the circuit, and the opposite logic 1 to cut off the voltage. Well, that's the thing I can share for now for the Arduino project, looking at the circuit design of the power supply. Guys, thank you for watching, and thank you also for subscribing and following my Arduino project. From the comfort of McDonald's and this nice latte coffee, bye for now, and see you in the next Arduino video.